Hi, Andy. I think we are getting the messages now in the chat box.
Okay.
So, did you want to invite somebody from each of the tables to present their work?
I think that's the quickest and easiest way.
Right. Table 1, can I have a representative, please? Should I just invite somebody? Andrew?
Yes, or when you say, can I have a volunteer, you might want to specify how you want to know who the volunteer is.
So,
Is it me?
the thing is, all you need to say in the chat box is yes or raise your hands using the more button. I'll put you on stage. I know Andrew was on the speaker list, so that's why I tried to use him to start with.
You've got to be more specific about Andrews, because all the best people are called Andrew.
I realized that bit. Right. Okay. So what I'm going to do is I'm going to open up this your screen image so everybody can see it. Okay. Let me also pull. Steve was on the table. Who else was there on the table? Steve. Yes. I will add Steve as well.
Yeah. Steve had some very interesting views that he was typing in, so you might like to bring him on to comment on it.
Please. I've just invited him. Is there anybody else on table 1 who wanted to come along as well to make some comments? Please leave a message in the chat box and I will invite them as well. So, Steve and Andrew.
Okay. Do you want me to go first, Andrew? Or
yeah, you go first.
Right, I've got to remember which ones I did. Right, the first one I put down is I thought that the knowledge base is only valuable if you take into account the following question. So basically, how would the knowledge base take into account the contextual history of the failure? As we all know, if you've got a repetitive use of something, then it's quite easy to turn around and say that it's failed after X many running hours. But if you've got a material or an item that is subjected to infrequent use, it's very difficult to capture that unless you capture the entire history. And then at some point, if somebody else is going to use that, you need to somehow normalize that for general use.
Yes, absolutely. We'll come on to a little bit of that in some of the following exercises, but you're absolutely right. Context is all important.
Right, the next one I did was the top 3 areas. I found really difficult to actually answer that question because I tried to put myself into a neutral person's mindset, and I found that all that did really was to turn around and say, right, throughout the CAD cycle, sorry, military term, but throughout the life cycle of the equipment. If I was a designer, then obviously that database would be particularly important for me in the earlier stages of its life cycle. If I was a through life support engineer, as I am, then the in-service aspects and things like that are more important to me. So the top 3 areas of the life cycle, I think it depends on who you are. I did look at it from a different angle. So the top 3 opportunities, I think it should be sold as environmentally responsible. If you can actually understand the longevity of the item that you've got, the true longevity, as opposed to putting excessive safety margins and things like that on, you can keep it in service, so you're using less materials, etc., etc. I think we also apply safety margins which may be excessive. So if we understand the individual items better, we may be able to confidently reduce those safety margins to a more realistic measure. And then obviously it's going to be a good saleable point is that if we understand it better, we've got reduced servitization costs or support costs or MRO costs, whatever term you want to apply to it. Ultimately, as Keith mentioned in one of the previous ones, money talks. So the opportunity here is that it's going to save someone some money.
Okay.
Where's it got?
So I guess in summary, do you see there being a decent value case for this, or is this a complete flight of fancy which has no value?
I think there is value in it, but the next one I was going to talk about was it is valuable, but because it's valuable, is that a potential blocker in itself? So the people that gather that data, it has got a value. So are they freely going to give that data away and put it into a database that everybody can use, or are they going to see it as a personal advantage?
Yeah. No, an interesting one that. So we have in the design of this thing got the concept that there would be some truly shared stuff, which is basically the fundamental physics, which is available to be harvested from public sources. But then you might have a private level of data, which was specific to your own organization. But at least within your organization, you could share the various bits of knowledge that all of the participants had.
Okay. I think that was mine. I think I'll hand over to Andrew and then see if I've missed any.
Yeah, I would be a little more and say, why not just rely on something which exists? As Andy says, some of this is in the public domain. But if you wanted better quality information, you buy a book. And if you want something really unusual, I got one that's just here, which I think is pretty unusual. I actually bought a copy of it. And I guess most of you are thinking, I don't want a copy of that book. Understanding rails and rail welding. It's much more about welding than it is about steels, actually. But you can buy the book, and it's quite an expensive book, about 60 quid. But it covers all that area. Whereas if I go on Wikipedia to look up something about, let's say, friction, fatigue, corrosion, all of our favorite degradations, I'll actually get a fair amount, but I won't get anything about those specialist areas that you might want. And I'm just a bit worried that if you get too specialized, then you get to the point where you've only got a very narrow group of experts and beneficiaries. And I just wonder if there's the risk that you lose it completely as somebody retires or leaves the organization.
Yeah, and I guess the other issue with a book and Wikipedia is it's only useful if a human reads it. So it doesn't neither lend themselves to automation of supply of data.
Yeah.
So that was our other key consideration in this, was you really want data to be pushed to the right part of the process that can consume it, rather than relying on a human having enough time and energy and knowledge to go and search out that information from appropriate sources.
Yeah, I mean, that's why web sources are good, and distribution electronically makes a big difference, especially right now, because it's harder to go and buy a physical book. So that particular example is a publication of the Permanent Way Institution. They do railway track stuff. And they do some other slightly more general publications. And one of them I wanted to get out to a number of trainees who were new to the field, intelligent researchers, fast learners, but they needed a new book. And that particular publisher has only put one of their books online, and it's as a Kindle download. And that's pretty good. It means that a lot of Kindle users could read it. However, you'd have to get it, I believe, through Amazon. And as a consequence, there are some countries in the world that we couldn't deliver it to because Amazon won't deliver to some countries. So it just ends up a bit clunky, because if it was general internet Wikipedia type stuff, you can be sure that all the people you want to read it can read it, but also the people you don't want to read it can also read it. That's the nature of publishing, isn't it?
Yeah. Okay. So I'm just, I guess in the interest of time, we probably ought to give the other two tables a chance to say something if they wish to, or we can move on as we see fit. So
I have got an image from another table as well, Andy. Let me open it up and let me share screen. Let me maximize however I can. Is that visible for everyone?
Yeah.
Could somebody post in the general chat which table this was? Lawrence, which table were you in? Do you remember? I think it's table 9. Can I have a volunteer who would like to discuss this from table 9 so I can put them on the stage? Okay.
Hello.
Hi, Lawrence. Hi.
Hello. Okay.
So could you run through the list which you populated from your table as well?
Okay. So the first area is identifying key degradation modes, but also perhaps even specific new ones. But if a degradation mode applies to, say, a particular alloy under various stress conditions, or even if it's applies to different alloys, obviously to different extents, but under the same type of stress condition, then that knowledge is useful, not just for one company contributing the information and distributing it amongst its affiliated organizations, but it's an opportunity for different companies to share the same lessons, so that they can all learn and benefit from the same exercise. Now, the problem obviously comes in with how much they're willing to share, but that's a natural part of the conversation. The second area is taking this information and feeding it back into the design process. So say, for example, if you have a stress condition or a particular geometry that is vulnerable in a particular context, then that information can feed back into the design process, reducing the overall how the degradation processes exhibit over the life of the component. And finally, the refinement of the data collection for mean time to repair and sorry, I think I wrote that wrong. It was mean time to failure and mean time to repair, so that the estimation of the life of the components can be improved, and an improvement in scheduling of the maintenance and overhaul.
Okay, that's good.
Summarize that. First one is to have a general understanding, common knowledge. Second is feedback into design. And the last one is in terms of MTBF, mean time between failures, or those kind of concepts in reliability kind of context. Okay, I've got one last table. I'm just going to stop sharing here. I know the name of the person who I did have a chat with. Wow, I'm going to put you on the stage. Sorry, I had to nominate you because I remembered the name. Hope it's okay. Did you want to give an overview of your table? Sorry, we didn't give much time. I think it's the first time we're running.
No, it's all right. Actually, that's on our side that we didn't manage to manage our time efficiently. So that's on us. Thanks, Bevan. Yeah, when we discussed it, I think I saw it mostly from a designer's point of view. The time where, or the stage where we have most control or anything is usually at the design stage, where you get to select your materials freely, select your geometry, select your configuration and everything. So and that is not only limited to the current manufacturer or designer, but it also applied to it's an industry-wide thing, because I think we're mostly talking about industries where there are lots of codes and recommended practice that people have to stick to and adhere to. So any common knowledge of the deterioration stage would definitely be quite valuable in that regard. So I think I thought that it would be an easy pick, but I don't think it is. But if I had to, I'll probably go from the top and go down, and then later on, that would be the manufacturing and testing stage, because then you would be able to put the right QA QC controls in place and to test the areas of common problems that you already know. This way you might be able to mitigate any of these factors, like improve the manufacturing process, like moving from casting to forming, or or choose a different material because of the available techniques that you have. And then third, I'll probably go for health monitoring, because that will enable you to do your maintenance planning efficiently in terms of inspection, scheduling, adjusting stock when it comes to spare parts, knowing which spare parts to stock and how much, and so on. So if I had to put my money on them, I think these would be the top three areas. If a knowledge base is valuable, I think it's very valuable as we go on right now from a data-driven world where everything right now is relying heavily on data. Everything what we used to call before ignorance factors or safety factors right now are called like load factors or materials factor in terms of design. So as we get to know more, we'll be able to quantify and improve and optimize our work. So and also what you do, one manufacturer might encounter a specific area, problems area that others might not. So you'll be also transferring that expertise and knowledge. It's not obvious. It's not always doable, because lots of large players in whatever industry, they kind of have proprietary data, and they kind of sometimes keep that data just for their own use for many reasons. But if it can be shared widely, and that will definitely enable improvement at a much faster pace than what it currently is. Thank you.
Thanks, man.
Okay.
Let's prod along, Andrew, I think. Is that okay?
Yep. Okay. So thank you for that. You've pretty much, I think, validated our own thinking, which is the earlier stages of the life cycle are the ones where you have the most opportunity to create an impact. So in particular, feeding into the design process is probably the single most valuable lever you can pull. So we'll talk a little bit now about what we can, what information do we need in a deterioration knowledge base, and that largely is predicated on our working assumptions about what as engineers we can do. So the simple way of thinking about the opportunities to make a change are, they fall into three basic categories. We can either do things that help us avoid damage occurring and the consequences that naturally come as a result. So changing the rate at which things degrade, and what we mean by failure when failure eventually occurs. We can do things around containing, which is catching it before the point where it fails, but hopefully at the point where you've extracted the maximum possible of use out of it that you can in a safe and reliable fashion. And then the recovery process, which is re-injecting health back into the product to get it back into a condition where you're comfortable to continue using it. So those are the three basic interventions that we see we have the opportunity to improve. So we then started thinking about, so what do we really need to know about deterioration? And if you think about those three stages of activity, stage one around avoid is essentially trying to manage the process of damage occurring. So there are things that we could learn and understand around the initiation point. So what conditions are required in order for damage to begin occurring of any type? What are the conditions that drive the progression of that damage? And is it an accelerating curve, as we show here? Is it a linear? Is it something that slows down over time? Or is it just a purely instantaneous damage that occurs at a point in time and then doesn't change going forwards? And what do we mean by failure? So do we understand how damage converts into something that we would worry about, and what is that sort of progression path from a physical change in your machine to something that you would consider to be a cause of a lack of functionality? So that's kind of the first set of data we think we're interested in. You then get into the contain activity, which is catching it before the point of failure. And you then get into two basic methods of doing that. One is a timed method. So you schedule some kind of maintenance intervention based on your belief and understanding of how things degrade, and try and time that so that it uses as much life as possible, but prevents any failures occurring, or prevents an unacceptable quantity of failures occurring. And then there's the monitoring process, which is understanding what you can measure and detect, which will be a reasonable indicator of how close to the failure condition you have approached. So that may be directly measuring the damage. It may be measuring something which is a consequence of the damage, or it may even be measuring the input parameters which create the damage and getting some kind of integral of the risk. But the difference is you are measuring something and using that as an indicator of where you are on the process. So understanding what you can measure and the best ways of managing a particular type of damage, again, might be important things to understand. And then finally, there's the recovery process. And essentially the things we have control over are how do we get to the thing that needs to be repaired or replaced? And then what are your relative options? So is there such a thing as a repair capability for the type of damage you're talking about? And is it cost effective? Or is replacement the only rational way of managing the problem? So understanding the degrees of freedom and what drives the cost in that recovery process, again, is a key area. I mean, to a large extent, when you're managing recovery, you are going to incur some cost. So it's mostly about the cost efficiency of getting the right outcome for the minimum investment of time, effort, and resources as you go through that. So they became our sort of shopping list of things that we thought we needed to understand. So just looking at the time, I might miss out the next exercise. But the thing I was going to, thinking of asking you to think about were really, if you went through that cycle, what kind of data would you find important? But as there are probably some more interesting exercises coming later, I'll skip that one, given where we are in the 2-hour session. So one of the things that we were thinking about is we did a little bit of articulation of what might a use case look like. So what are the real questions that somebody performing a particular role might have? So rather than picking on the designer this time, this example is around a maintenance engineer. So in this particular instance, it's somebody who is managing a piece of infrastructure with pipe work, which is pumping material around, and they detect a leak in a pipe. And they're trying to understand, essentially, number one, how do I stop that leak? So I have this problem, it exists here and now, and I have to resolve it in order to get the equipment back into operation. They then want to understand how to identify the cause of that problem so that they can understand how to inspect for it and to determine if they're about to get another leak somewhere else in the system because it's been caused by a similar type of problem. And they'll want to know what they can do in the future to put preventative measures in place to know that a leak is about to occur before it occurs, so that they can start to time the maintenance for when it's convenient to them, rather than waiting for it to announce itself and create a disruption in the production process. So essentially what will happen is the individual will go through a series of question and answer sessions, assuming that they don't have experience of this type of problem before. The very first question might be, what options have I got to prevent or correct the leak that I'm currently seeing in the pipe? They may then have some questions about which of those options is the best one to adopt. So for my recovery processes, do I understand what the cost and time implications of each of them are, or are there any prerequisites of things that have to be true in order for that particular method of recovery to be applicable? They'll then get into thinking about, why did this happen? So starting to understand what the potential root causes might be, and how likely each of them are to have contributed in this particular case. And if we've got those root causes in place, does that imply that there might be other deterioration or damage mechanisms also occurring as a result of those conditions that we might also need to inspect for? And once we've identified the list of potential threats that we think may exist, we may want to know how to prove to ourselves that they don't actually exist in this particular case, or to get an estimate of how much residual life remains in the system to be used. So you can see, as you go through this process, essentially it is going to be a collection of question and answer type dialogue between the user of a knowledge base and the content of the knowledge base. So very much we're thinking about the process of how do we enable an intelligent dialogue to take place. So we're trying to think about ways to structure the knowledge base content in a way that allows you to have that kind of level of interaction with it. So potentially the same elements of information are used many times to answer different questions, but potentially combined or manipulated in a different way depending upon what you're asking. So that kind of leads us into the area of thinking about, how do we describe deterioration? So we've put some effort and thought into the concept of a taxonomy. And one of the easiest ways to kind of visualize it is using this type of diagram. So what we tend to see as symptoms are the impacts, so things that happen that we attach a consequence to. So my car stopped working. I had to take my car to the garage. My car leaked oil on the driveway and created a slip hazard. So those are the end points which create some kind of problem that we would attach a level of pain or value to. So there's a value to avoiding that kind of outcome. And then generally speaking, you can say my car caused it, but the reality is it was some part of my car that actually created that particular outcome. And it may be a combination of parts which together all had some kind of loss of functionality or reduction in functionality, which together led to an outcome. So we'd be interested in understanding what is the particular feature or sub-element of the thing or the part which has created my problem. And so we kind of describe that as, we talk about it as being the context. And the reason for that is those outcomes and what causes them are going to be very, very variable between who's using it, how they're using it, what they're using it for. So that's probably not something where you could have a universal knowledge base with any degree of meaning, because what was of interest to Rolls-Royce would not be of interest to BAE Systems and would not be of interest to Bombardier Rail, because the context in which our products work are very different in many cases. So there won't be a single version of the truth that we can all share. The other side of the equation, however, is about the physics. And once you get down into the level of saying, well, there are types of damage, and damage affects physical things. And if you describe your physical thing at the level of a feature, like a flange or a skin, or a bracket or a bolt, then actually they do start to become very common across industry players. And when you get into talking about things like oxidation or corrosion or low cycle fatigue, then you would argue that those things don't really care about the context of use. They are dictated entirely by physics. And the only thing that we really need to understand is the causal driver network. So my oxidation is caused by something, and the things that cause it can either be physical attributes, so things you could measure, or they are preceding processes which have created a state which then allows my oxidation to take place. So we believe that there is this sort of causal network, and you can work back and back through the driver layers until you eventually reach some kind of terminating condition, or you find a loop where actually there's a circular argument through the causal chain as you go through. So that's our kind of underlying view of the key elements of the taxonomy that underpin the sorts of things we're going to be interested in. And in particular, and it's kind of addressing the point that was made earlier, context is all important. So we think the physics element is likely to be relatively stable and shareable between organizations. However, parts of that physics diagram will vary between organizations. So the drivers that cause the oxidation in a gas turbine engine may be very different in weighting to the drivers that cause oxidation to take place in a train environment, or a domestic washing machine, or anywhere else where we see that kind of thing happening. And the consequences may be utterly different as well. So the degree to which we would worry about those drivers may be very, very different. So that makes up our kind of backdrop assumption. So just as a little bit of a thought exercise, I suggest probably not do a full 10 minutes, maybe only do 5 minutes on this one, Pavan, but just have a quick go at trying to expand this diagram. So if oxidation is the physical manifestation of degradation we're talking about, how would you expand out this diagram of the causal factors? So is time an end node? You know, there is nothing that causes time and therefore it becomes an end point, or are there in fact factors which influence time? So I guess if we can just go back to the table, I suggest try and do it on your own whiteboard and jot down things which are links. But just spend 5 minutes trying to understand if that's an easy or difficult task to do. And please constrain yourself. You're only allowed to write a maximum of 2 words at each of the nodes in order to keep it at a relatively simple level.
If I may add, please choose easy mechanisms and how you would represent them. 3 levels is more than sufficient, I think, Andy, because some people can go to the nth degree. Yep. But again, we welcome your comments and see how things are. I'm going to put us back onto the floor. You will have a timer which will go on the top of your web browser as well. I will set it for 5 minutes. Okay? And again, as before, a gentle reminder, please open up the whiteboard as you start. Turn on your cameras, somebody be a scribe, or everybody can work on the same whiteboard. And please take a picture, post it into the chat box so I can actually pull it up and show it to everyone. Okay. For those who are just joining us from other sessions, so on and so forth, this is one activity. A table of 4, maybe 5 maximum. If you find yourself only in pair of only 2, please move to another table. Thank you.